You are watching the lesson video 2.10 on average rate of change. Now, the average rate of change is just a fancy way of saying the slope between any 2 points. And this concept is going to carry with us through the whole course of algebra. We can find the average rate of change between any 2 points of any function. So right now, we are just going to apply it to functions in general. So exercise number 1 says Max and his younger sister Evie are having a race in their backyard. Max gives his sister a head start and they run for 20 seconds. The distance they are along in the race in feet is given with Max's distance. His function is m of t, and Evie's distance is given by the function e of t. And if you take a look, both of the kids, their graphs are shown below. So here's Max's race and Evie's race. Let's read question A. It says, how do you interpret the fact that m, so right away we notice we're dealing with Max's function, m of 12 is equal to 30. Well, we know that when we input 12, that's our x value, we get out 30. So if we put in 12, we get out 30, which is this point right here. You have to be careful as well because the scale is a little bit different for each of the 2 axes. So notice how each grid mark is equivalent to 5 feet for the y, and for the time it's 2, 4, 6, 8, 10, so 2 seconds for every one of the grid lines. That's how I can pick that point. So what does this mean? Well, this means that after 12 seconds, Max has ran 30 feet. Okay, so part B says if both runners start at t equals 0, that's the time is equal to 0. Well, that makes sense because we don't want to go into the negatives. We don't want to go back in time. So we're going to start at the initial value of the time being 0 seconds. We need to see how much of a head start that Max gives his little sister. And how can we tell? Well, we need to compare the 2 functions. So as we can see here, Max starts at a distance of 0 feet, so he hasn't traveled any far, or he hasn't traveled far at all. He hasn't moved. But look here. Evie does not start at 0. She actually starts at 25 feet. That is her initial value. So how much of a head start did Max give his little sister? That would be 25 feet. And we know this because it is the y-intercept. Okay, moving on. Does Max catch up to his sister? And how can you tell? This is an interesting question because if you look at the graph, it does not appear that Max is intersecting. So what we need to find out is, are they traveling longer than 20 seconds? Which I'm going to just read back in the problem. It says they run for 20 seconds. So what do you think? Is this graph going to keep going? The answer is no. So will Max ever catch up to his sister? No, the graphs do not intersect. Okay, let's move on to D. It asks, how far does Max run during the 20-second race? Well, let's see. In the 20 seconds, where does he end? It looks like it's this point right up top here. And I'm going to look all the way across to get my y value, which is the distance, and it appears that Max has run 50 feet. Now we know that he has actually traveled this distance because he began when he was 0 feet, or he had traveled no feet at all. So obviously from 0 to 50 would be 50 feet. Now, Evie, on the other hand, ended right here. So she ended at 60 feet. However, we can't say that Evie ran 60 feet because she didn't start at 0. So we have to be a little careful. That's why it says, what calculations can you do to find this? So let's take our 60 and subtract away 25, which gives us 35 feet for Evie. I think part E is probably the best question that connects our average rate of change to this particular problem. And it asks us, how fast do both Evie and Max travel? And it says, in other words, how many feet do each of them run per 1 second or per second? And it said, express your answers as decimals and attach units. Okay, so in order to do this, I am going to set up a table. So why? What am I doing here? Well, I need 2 points. I need to see where or how far Max is traveling in feet per second and Evie's speed, also in feet per second. So let's pick a couple points off of Max's graph. I really like the point 0, 0. And let's also pick, well, there's 0, 0. Let's also pick, oh, I don't know. How about the point 6, 15? Now I could pick any 2 points because this graph is linear. That might not always be the case, but it is in this case. So now I need to see how much did I jump to get from 0 to 15? Well, I added 15. And how far did I go from 0 to 6? Or what did I do to get there? Well, I added 6. So in order to calculate the average rate of change, that would just be 15 divided by 6, which is equivalent to 2.5, and this, of course, is in feet per second. Let's go ahead and do the same thing with Evie's graph. So now we need to get 2 new points, but I'm still going to set up my table of values. So I'm going to make an X and Y chart again. And the first point I kind of like because it starts with a 0, so this is a point 0, 25. And let's pick any other point. So there's a 0, 25 point that I picked. Now I only want to pick the points that look nice on the graph, and I can't seem to find a really good one except for this last one right up top here. So the point 20, 60. Okay, so let's see how the y has changed divided by the x. And remember, the reason why I'm doing this is I'm trying to find the feet per second. That's why I'm putting the y up top, because the y is the feet and the seconds is the x. So to get from 25 to 60, it looks like we added, what did we add? 35? And to get from 0 to 20, looks like we added 20. So to write this, we're going to, you guessed it, take 35 feet, divide that by the 20 seconds, and we end up getting 1.75 feet per second. So basically that tells us that Max was being nice because clearly Evie cannot run as fast as he can. So in summary, finding the average rate of change is the same as finding the slope of a line between 2 points. And this is always going to be the change in y over the change in x values, which you probably remember doing from last year. You probably did a ton of slope stuff last year because you worked a lot with linear equations. Now this year, I want to always see a table whenever you're trying to find the average rate of change. So let's take a look at exercise number 2. Because remember, in algebra, it's all about making the connection, and tables help us to make a connection. So exercise 2 says consider the function given by f of x is equal to x squared plus 3. Find its average rate of change from x equals -1 to x equals 3. Well, right away, I can see I'm given 2 x values, which is great news for me, which means I'm going to immediately put -1 and 3 in my table. Well, the problem here is I don't have my y values for those x values, but that's not a problem. I'm going to go ahead and find them. I'm going to find f of -1, which really just means I substituted -1 into the x squared plus 3, so that's really -1 squared plus 3. Well, following order of operations, I have to do my exponents. -1 times -1 is 1. And don't forget that you can use your calculators. But 1 plus 3 is 4. So that means when I input -1, I get out a 4. Let's do the same thing for inputting 3. So if I input 3 into my function, I'm going to get 3 squared. Let me just show my work a little separated here. 3 squared plus 3. Well, 3 squared is 9, plus 3 is actually 12. So when I put in a 3, I get out 12. Now all we have to do is show our calculations. So how did we get from 4 to 12? Well, I added 8. How do I get from -1 to 3? Well, I had to add 4. And if you're ever stuck, you can always subtract, go backwards in the table. So what do I mean by that? 3 minus a -1 would give us that 4. Now to calculate the average rate of change, this would just be 8. The change in y divided by 4, the change in x, and 8 divided by 4 is 2. All right, I like exercise 3 a lot because it gives us the table. We just need to figure out what parts of the table are important to us. So it tells us the function, and it says which of the following gives the average rate of change over this specific interval. So looking to my table, it gave us a domain, and we know it's a domain because, well, looky here, there's an x right in there. So let's jump to our table. We are looking at the point 2, 9, and 6, 3. Well, smooth sailing from here on out. How did well, I don't want that. Let's use our pen. How do I get from 9 to 3? Looks like I had to subtract something here. Didn't I take away 6? How did I get from 2 to 6? Well, it looks like I added 4. So to calculate this average rate of change, this would be -6 divided by +4, which, isn't one of my answer choices. But wait a minute. Looks like I can simplify this. I can divide each of those numbers both by 2 to get -3/2, which is answer choice 1. Okay, exercise 4 talks about Frances selling glasses of lemonade, and this is the function that models the number of glasses she has sold, G, after T hours. And it says, what is the average rate at which she is selling lemonade between T equals 2 and T equals 6? So already I know my 2 T values, which are really my x values, it looks like, because that's my input. So on the graph, let's find where t, or x, is 2, and where t, or x, is 6. Okay, well, let's take a look. Right away, I can see that one of the points is pretty easy to find, and the other one is not so easy. Since I'm trying to find the average rate, I need to make a table. So So let's go ahead and do that. Let's make an x and y table. I know my two x values already. They said it right in the problem, which are 2 and 6. Now my first y value is pretty easy to find because it's at a nice, pretty intersection point. That's the point 2, 4, which we see here. Now I'm not totally sure what the output is when x is 6, so let's use our equation to help us. I'm going to take my function g of t and let's input 6 and see what we get out. So that would be 6 squared plus 4, all divided by 2. All right, using order of operations, I'm going to do 6 squared, which is 36, plus 4 all divided by 2. And 36 plus 4 is 40. Divided by 2 is 20. So if I input 6, I get out 20. Okay, I'm just going to scroll up a little bit just to see, oh yeah, it really does look like it's at 20, but it's really hard to tell from the actual graph. So let's now go through and do our calculations. How did I go from 4 to 20? I want to see how my y's have changed. Well, it looks like I have added 16. And how did I go from 2 to 6? Well, it looks like I added 4. So to find the average rate of change, we're going to take our change in y, divide it by our change in x values, which is really 16 divided by 4, which is 4. So just to sum everything up, when we're finding the average rate of change, we're finding the slope of a line between 2 points. So whenever we do this, we should make a table, find how the y's change and how the x's changed, divide them, and write it as a single value or a simplified fraction.